This lesson is Module 4, Topic 2, and it's the second part of Lesson 4, starting on page 599, ending on 602, but we'll get to our assignment on 603. So this is our first formative grade for quarter 4. And also it's the last lesson. So last lesson of this module and topic. So because we did the majority of this lesson prior to spring break, we only had 2 lessons really to do after spring break. So we'll be reviewing and then taking our module 4 topic 2 test and then moving on to the last module of the year. Okay. All right, anyways, for now. We're going to be finding, so we're going to use the Pythagorean theorem, but we're using it with 3-dimensional figures, so predominantly it's going to be rectangular prisms. So let's review from last lesson. It says, in the previous activity, you determined the length of the diagonals of 2-dimensional plane figures. In this activity, you'll determine the length of a diagonal in a 3-dimensional figure. So just talking about like the differences between the two. But let's go and get to this one. All right. So it says a rectangular box of long-stemmed roses in 18 inches in length, 6 inches in width, and 4 inches in height. Without bending a long stem rose, you must determine the maximum length of a rose that will fit into the box. Okay. So number 1, it says, what makes the problem different from all of the previous applications of the Pythagorean theorem? So because we're so used to using 2-dimensional figures, it's a little bit harder with this. It says this problem will require I'm going to abbreviate the Pythagorean theorem of PYTH for Pythagorean, THM for theorem. In a 3-dimensional, put 3D situation. Okay. And we have a visual here. So number 2, compare a 2-dimensional diagonal to a 3-dimensional diagonal. Describe the similarities, describe the differences. So what are some things that we see that are the same? So, we'll say same. Right, at least for this, right, when we talk about vertices, we're talking about corners here. So these are 2 vertices, these are 2 vertices. At least for this is that we have, we do not have a line segment. So they do not have line segments that connect vertices. Line segments. I should say on the figure itself, line segments that connect another vertex. Okay, so line segments connecting any vertex to another vertex does not share a face or an edge. So, right, notice how this vertex we're not using this one, and we're not using this one, which is right next to it. Right, this one right here, some that are next to it, this one, and this one in a 3-dimensional figure. So they're not next to it. And then another thing here is, right, 2-dimensional diagonal shares the same plane. So we'll say that this is different. We'll say a 2D diagonal shares the same, and we're going to say plane. And what plane means, we talked about plane before in various geometric concepts, but a plane is just like a flat surface. So like here, I'm going to put in parentheses, like think about your paper that you're writing on right now. That's a flat surface, that's a plane. So this, right, these are 2 points that are on the same plane. Here, right, these 2 points that we have highlighted here, I'm going to erase these X's. They're not on the same plane, right? So that's something that's different between them. The 3-dimensional diagonals does not share a plane with any side. Okay. And number 3, which diagonal represents the maximum length of a rose that can fit into a box? The 3D diagonal represents the maximum length of a rose that could fit into that box. So we'll just say the 3D diagonal fits the maximum length. Let's put max of a rose that fits. Okay, so like this distance here, this dashed blue line, is not the same as this dashed blue line here because it's slanted. Maybe think about like when you try to fit something into a box, maybe you're wrapping some type of package, right? You can fit something here because it can maneuver in another angle and fit within like the same dimensions. Okay, anyways, moving on to the next page, page 600. We're now on number 4. We're gonna draw and annotate on this rectangle off to the right, or sorry, rectangular prism off to the right. So number 4, consider the rectangular solid shown. So first thing we're gonna draw, it says draw all the sides in the rectangular solid. When it says solid, it just means prism. You cannot draw those that you cannot see using dotted lines. So I can see the front side of this and the side and the top, but I cannot see, as best we can, I'm gonna draw dashed lines. Let's draw something like this. A horizontal that kind of meets, or sorry, vertical and now horizontal. Okay, I should arrive at that point right there. Yeah, close enough. Okay, so first one, done. B, draw a 3-dimensional diagonal in the rectangular solid. So 3-dimensional diagonal. So I have to pick opposite points in this box. Let's say right here, this is back, right, and downward. We're gonna go with all the opposites. We're gonna go up, left, and front. Let's go ahead and connect that. I'm gonna draw a red line for this. Yeah, let's make it dash though. Okay, so this is the diagonal. We're probably gonna find the length of that later. C, let's consider the 3-dimensional diagonal you drew in the rectangular solid is also the hypotenuse of a right triangle. When a vertical edge is one of the legs of the right triangle, so one of the vertical legs here is right here. And you know what? I'll make that solid because we can see that. Where is the second leg of that right triangle? So I want you to think of this figure here, where we have two sides, the diagonal, we have this vertical line. Now I've got to draw a horizontal line. Where is this horizontal line coming from? So it's coming from this point and this original vertex. We're going to connect that. So that in itself is another diagonal. But let's try to do the best we can to connect these two. Okay. Right, so what I have drawn in red, it may be kind of hard to see, but this is a right triangle. So it says, draw the second leg using a dotted line, then lightly shade the right triangle. I like for you to shade everything that's bounded within this red region. I'm going to try to do this with my highlighter tool. We're just coloring it in. Okay. E, determine the length of the second leg that you drew. So since everything is like so slanted because we have a 3-dimensional figure, I want you to think of the floor of the box. Okay. The floor of that box, I'm going to put this in black, right? The base of that is 18. And the height of it is 6. So this is A, this is B. This red dashed line that's right here, that I'm drawing this black dashes on, that's C in the a diagonal of the ground. Okay, so we're going to use for the Pythagorean theorem, so 18 squared plus 6 squared equal to C squared. 18 squared is 324. 6 squared is 36. And pretty much what you do is you add it. That's 360. And you take the square root of it. So square root of 360. Okay, we wait for the add to go away. 360 square roots. It is 18.9, but the hundredths place is a 7. The 7 will make that 9 go up. And if that goes up, $18.97 is really close to $19. So we're going to put this actually is instead of rounding to a whole number, or sorry, to a tenths place, rounding to a whole number. This is, we'll put C as approximately equal to $19, or in this case, it's actually 19 inches. Okay, now this is only part of the battle here. So we know that the bottom part of this red right triangle is 19. Okay. Now, F, determine the length of the three-dimensional diagonal. Now, awesome, right? We have the 19 here, but we need to figure out what is the height of this. The height of the entire rectangular prism, as you can see right here, the height is 4. So I'm just going to put a 4 right here. 4 inches. So to find our final answer of the diagonal of this rectangular prism, we're going to use the 4 and we're going to use this 19 to find what it's approximately equal to, right? We did have to round for the first one. So 4 and 19. So we're going to have 4 squared plus 19 squared equal to C squared. This is 16. 19 times 19 is 361 equal to C squared. If you add this, this is 377. We're going to take the square root of that. 377 is 19.4. 19.4 inches is our final answer. So G, what is the length of the three-dimensional diagonal represent in terms of the problem situation? It's pretty much just this. Right, it's 19.4 inches. That's the length of, let's just say the length of a rose, or the biggest rose that we can fit into this box. Any bigger is going to get squished. Number 4, describe how you use the Pythagorean theorem to solve this problem. What we did, how I would describe this is that we used the Pythagorean theorem twice. Right, one to find the base of the, we're going to say diagonal triangle, right triangle. And then the second time was using that, we had to use our answer in the next time we used it, is then we found the diagonal of the entire shape. Okay, so pretty much this is just using the Pythagorean theorem twice, right? I would give you a problem, and it's just combining two problems into one. Okay, it's just the answer for the first one is needed for the to derive the answer for the second one. All right, and we're pretty much going to finish up on next page 601. We're going to skip number 1. It says using diagonals to solve problems. We're now going to apply our understanding of what we just did to these other problems. to figure them out. Okay. So number 2 and number 3 is our main focus. Determine the length of the diagonal of each rectangular solid. So you can see this triangle that's formed, right? I'm going to color this in just so you can see. Oops. All right, we're looking at this red triangle that's inside it. It's diagonal. So what we first have to do, right? We know what the height of this is. The height of this is 10. But I'm going to look at the floor, right? Always start with your floor. The floor of this is a 6x4 blue floor. We're going to use 6 and 4, right? Because this is 4 right here. So that we can figure out what this length is. I'm going to put a star right there. Right? It may not seem like it, but this is actually a right angle. Visually in 3 dimensions, because of our perspective, it doesn't seem like it. But what we're going to do, we're going to do 4 squared plus 6 squared equal to c squared. This is 16. This is 36. Oops, equal to c squared. If you add this, 16 plus 36 is 52. And then we're now just finding the square root of 52. Okay, square root of 52, if you plug into your calculator, I'm just going to give it to you. This is 7.2. Okay, that tells us that this right here, oops, I'll put 7.2. Right, I'm going to use that 7.2 and the height of this red triangle, 10, to find, now I'm going to use the Pythagorean theorem one more time to find the diagonal of the entire rectangular solid. So we're going to put 10 squared plus 7.2 squared. Doesn't matter which order you go, equal to c squared. 10 squared is 100. 7.2 times 7.2, what is that? Okay. 7.2 squared, 51.84. All right, if you add $100 plus $51.84, you're going to get $151.84, right? If we take the square root of that, and let me just add 100 to this. And take the square root of it, it's 12.3. So 12.3, and this is inches. This is our final answer. This is the length of the diagonal. Okay, so first one we did is we had to find the diagonal of the floor, and then we use that number to find the diagonal of the entire shape itself. Okay. I'll leave this one 3 as a you do. Your final answer should be 11.3 meters. But try to work it out, see if you can get that. You will use the Pythagorean theorem twice. Try to find the diagonal of the floor first, and then the diagonal of this entire shape. We're going to go through number 4 though together. It says a plumber needs to transport a 12-foot pipe to a job site. Okay. His van's interior is 90 inches. Oh, so we're looking at inches now. 40 inches in width and 40 inches in height. Will the pipe fit inside his van? Okay. So we've got to use, I think it's best that we draw. Whenever you have a story problem, always draw. So 90 inches. Okay, as best you can, try to draw some type of rectangular solid or just some type of box. I draw it like this, then I go like this, then I go like this. We're also going to have to put dashed lines. Okay, let's say 90, we'll say 90 inches is this, 40 inches is this, and then another 40 inches is the height. Okay, we always got to start with the floor. So the floor, I'm going to highlight that in blue. Okay. And I'm going to draw like how the other one is drawn. So this, we're going to go upright, and then we're going to go diagonal. But I'm going to focus on this right here. Right, maybe this is also 40. So this is a 40 by 90 blue floor. Let's use the Pythagorean theorem to find the diagonal. So 90 squared plus 40 squared equal to c squared. 90 squared, so what's 9 squared? 9 is 81. The square just tells you how many zeros to put, so we'll put 2 zeros. 40 squared is, well, 4 squared is 16, and we're going to put 2 zeros. If you add this together, that is 9,700. That's a big number, but if we take the square root of that, we're going to get a nice number, or a nicer number. You can plug this into your calculator, but I'll give you, this is approximately 98.5. Okay, so that means that this right here is 98.5. I'm going to highlight the rectangle that the triangle that we actually want to use in red, which is this part right here. Right, that's why it's really important when we take our test or work on our assignment. We're drawing figures whenever we have a story problem. Otherwise, it's really tough. The height of this, right, is 40. So I'm gonna put a 40 also right here. So this is a 40 by 98.5 inch right triangle. So let's use that. We're gonna use 40 and 95.5 or 98.5. Oops. 40 squared plus 98.5 squared equal to c squared. 40 squared, that is, we just did on the last one, is 1,600. 98.5 squared. I mean, we actually technically did that in the past. It's actually this number right here. It's 9,700. But let's just go and plug in 98.5 times 98.5. 98.5 squared. Yeah, it's really close to that 9,700 number. I'm actually just going to put 9,700. Equal to c squared. And if you add this, right, what is 97 plus 16? 3, this is 11,300 equal to c squared. Take the square root of both sides. Square root of 11,300 square root 106.3. 106.3. So this is our final answer. This is in terms of inches. But we have to be careful with this because the problem itself said it's a 12-foot pipe, right? So we're going to use our understanding here, right? We know that there's 12 inches in a foot. So 12 inches is equal to 1 foot. So I'm going to have to divide our answer by 12 to see if that's equal to or more than or less than 12 feet. So 106.3 divided by 12. 8.85, this will look like it's 8.9 feet. Okay, 8.9 feet. So 106.3 inches is about 8.9 feet. So will this thing fit in our van? Nope, it's 12 feet, and our van can maximum fit something less than 9 feet. So we're going to say no, does not fit. Okay. All right, we're going to leave page 602 as a you-do. This is talking about the ant and the fly from the beginning. And then our assignment. Your assignment is on 603. We're doing all of number 1, number 2, and number 3, and number 4 on the back side. We're just going to skip 5, and you don't have to do the stretch. So just the front side and these 3 problems on the back side. Okay. All right, let me know if you have questions, but let's get started on our assignment.